This is Biostats Assignment 3 Anova with Hunter, Marcelo, Roberto, Kevin, and Sikongi, Team 26. To begin, a published paper compares the links of 3 different bird species, A, B, and C, and Anova rejects the null hypothesis A equals B equals C at P equals 0.0001. Your colleague shows that paper as proof that A and B are significantly different. Give at least one reason that he may be wrong.
Okay, so first of all, how to find ANOVA? There's several steps. Essentially, we want to understand the what the null hypothesis is, which is A equals B equals C, and then also try to find the alternative hypothesis, which means that there's at least one difference among the means of the groups that exist with an alpha that's 0.05. Significant, so making it significantly different. So to find, then you find what the difference is, which is k minus 1. The difference is between, and then the difference within, which is n minus k. And then you find the difference total, and then after that you find the f critical, and you do that from the degrees of freedom table, and you calculate afterwards the mean and the grand mean. Then you calculate the sum of squares total, the sum of squares within, and afterwards with that you can also find the sum of squares between. Finally, you calculate the means of the squares between, which is the variance between, and the ms within, which is the variance within. And finally, you calculate the f statistic, which is the ms between over the ms within.
Okay. Our colleague tells us that A and B have statistically significant differences. It is also possible, however, that the difference between B and C is insignificant. Additionally, it's also possible that all 3 are different. The solution then becomes a post hoc analysis to further test the validity of our colleague's assertion that there is indeed a difference. Multiple comparisons can be made in that regard in order to that will increase the likelihood of a type 1 error.
So we believe that because of the multiple comparisons that increase the likelihood of type 1 error. And just a reminder, type 1 error is the rejection of the null when the null is true. And this is also known as the alpha error. And to account for this increased likelihood of the type 1 error, we're going to use we could use the Tukey-Kramer, the Sheffy, or the Bonferroni. But for this particular case, we will use the Bonferroni analysis.
Okay, so as we have said, we are doing the Bonferroni. And since there are 3 groups, A, B, and C, the number of pairwise comparisons is 3. So the group 1 and 2, and then 1 and 3, and then 2 and 3. So our level of significance is 0.0003.